The universe is a brain, and it's having a stroke. The moment the universe flatlined. The last radio beacons blinked out one by one, quiet dots falling off a map. Between the islands there was only dark, no new signals, no rescue, just distance growing faster than any engine could cross. Filaments thinned to whispers. The web that once moved matter, light, and meaning went slack like synapses starving for blood. Here's the part that still bothers me. It didn't fail with a crash. It failed with forgetfulness. Expansion kept accelerating. Connections kept dying. Somewhere back in time was a stroke-like moment, one threshold crossed that made this ending inevitable. To hear it, we need to rewind. Two maps that shouldn't match, but do. Take a neuron forest and a sky full of galaxies, and you'd think the resemblance stops at poetry. But line up their maps and patterns start shaking hands. Both worlds live on sparse wiring. Both prefer short paths and tight clusters. Both balance reach against cost like someone's paying the bill. Start with topology. In brains, the connectome isn't a mess of wires. It's modular clusters linked by selective highways. In the cosmos, we call them halos and clusters at the nodes, filaments for the highways and yawning voids between them. In each case, a few hubs carry a lot of traffic, while most nodes keep to modest degrees. That skewed degree distribution isn't an accident. It's what you get when growth rewards connection, but wiring is expensive. Now look at clustering. Neurons love local neighborhoods, mini networks that think together, then pass messages along to other neighborhoods. Galaxies do a similar dance. They pile into groups inside larger superstructures with filaments tying them together across surprising distances. The result is small world behavior. The average path between 2 points stays short, even when the network is huge. That's efficient. It means information, energy, or matter doesn't slog through endless steps to get where it's going. The shocker is scale. One system is measured in millimeters, the other sprawls across billions of light years. Yet when researchers compare basic network statistics, clustering coefficients, path lengths, modularity, even the shape of degree distributions, the numbers often land in comparable ranges when normalized. Studies by Franco Vazza and Alberto Felletti, for example, highlighted quantitative overlaps between the brain's connectome and the cosmic web. Not identical, comparable. Enough to raise an eyebrow, not enough to declare a revelation. So let's be honest about boundaries. Similarity doesn't mean sameness. A brain fires electrochemical spikes across synapses. The cosmic web moves gas, stars, and dark matter under gravity, kicked around by radiation and feedback. There's no central processor in the sky, no unified mind pulling levers. What we're seeing is convergent architecture. When you push a system to be efficient on a strict budget, it tends to pick the same tricks. That budget matters. Brains can't lay infinite axons. They'd overheat and run out of space. The universe can't smash all its matter into bridges. Gravity would win locally while expansion wins globally. Both systems solve the wiring cost problem by using hierarchies. Dense local clusters for heavy lifting. Long but sparse highways to keep everything within a few steps. It's a fractal-like compromise. Self-similar patterns repeating across scales, but with variation that keeps the whole thing adaptive. Energy and information flow reveal the parallel from a different angle. In cortex, spikes travel along dendrites and axons, shaped by synaptic weights that strengthen or weaken with experience. In the cosmic web, material flows along filaments into halos, while radiation, winds, and jets blow back out, sculpting the corridors. The push-pull creates feedback loops that are eerily connectome-like. Reinforce productive routes, prune the wasteful ones, keep paths short, avoid redundant, expensive sprawl. Here's what nobody expected at first. Across roughly 27 orders of magnitude in size, both networks land near similar efficiency sweet spots, short paths, high clustering, sparse global wiring. It hints at a shared rule: maximize throughput under strict constraints. Different physics, same math. The details diverge, but the blueprint rhymes. And this isn't just simulation aesthetics. Large surveys like SDSS and DAISY have directly mapped galaxy filaments and voids across billions of light years, revealing the same modular, small world geometry in the sky that the statistics predict. Still, analogy is a tool, not a conclusion. It helps us ask sharper questions. For example, if brains and the cosmic web both settle on small world layouts, what happens when you stress those layouts? In neural tissue, cut oxygen and the network narrows. Connections fail from the edges inward. In the universe, accelerate expansion and filaments stretch thinner. Distant nodes slip out of reach. Hold that thought, because this is the parameter that ties the maps together. Efficiency under sparse wiring isn't a luxury, it's a necessity, and it's fragile. The very designs that keep path lengths short also concentrate vulnerability in the long bridges. Break enough of them, and the network stops being one thing. If that's true, there's a natural next question. How did the cosmic web assemble a layout so efficient in the first place? To understand the flatline we opened with, we need the moment the cables went live, the first time this universe found a way to be connected. Birth of the cosmic network. 3 minutes after the Big Bang, the physics was simple. Hot plasma, no structure, just pressure and light. The weirdness came earlier in the last sliver of inflation, when quantum jitters were blown up to macroscopic seeds, over and under densities at 1 part in 100,000. Quiet at first. Gravity turned up the volume. As the universe cooled and expanded, overdense regions tugged a little harder and attracted more matter, deepening wells. Underdense patches bled into growing voids. In between, matter didn't fall straight in. It slid along sheets and ridges into threads. The web didn't need design, it precipitated from geometry. Around 380,000 years in, electrons and protons paired up, the fog lifted, and the cosmic microwave background streamed free. Dark matter kept gathering. Baryons, ordinary matter, needed time to cool and settle. Millions of years later, the first halos hit the right mass and density. Gas collapsed, heated, cooled by primitive chemistry, and ignited the first short-lived metal-free stars. They flooded neighborhoods with ultraviolet light, detonated and stirred gas, sometimes blowing material back into filaments. Crude plasticity. Use a path, strengthen it. Overuse it, disrupt it, then let it regrow richer. Reionization spread as bubbles of transparency around infant galaxies and black holes. Bubbles merged along filaments where galaxies sat. The network's first firing. Geometry began to carry radiative influence, regulating the gas that would feed the next generation. Feedback mattered. Supernovae and early active galactic nuclei throttled inflows, cleared choke points, and redirected streams. Too little and halos overate, too much and corridors starved. The rhythm emerged. Inhale along filaments, exhale through winds and jets, keep lanes open and distances short. The skeleton thickened. Small halos merged into larger nodes. Filaments braided and sometimes snapped and rejoined under shear. Voids grew emptier as their boundaries sharpened. New galaxies formed where pathways already existed. Supply lines were destiny. Environment wrote biographies. Junctions feasted. Thin spurs went lean. By the end of the first billion years, telescopes and simulations agreed. Most galaxies lived near filament spines, and most stars formed where supply and pressure balanced. Physics turned tiny differences into arteries and organs. Complexity set up shop where connectivity was best. But success carried a warning. Small world networks thrive on dense local clusters plus a few long bridges. The cosmic web achieved that mix because matter was scarce and expansion kept stretching the canvas. Every bridge cost mass. Every detour cost time. Performance increasingly depended on keeping those filaments intact. Where you sat on the web decided your future. A galaxy with 2 fat pipelines could ride out a bad epoch. One with a single, thin, umbilical risked quenching if that link faltered. The web wrote possibility into space. And here's the hinge to the present. Building a network is one thing, keeping it stable is the real trick. Early on, gravity drove while pressure and feedback kept lanes from clogging. Later, a quieter force took the road. Expansion didn't just stretch distances, it thinned the bridges that made the universe small, world efficient. The cables went live. Now watch what starts to tax them. The network rulebook, efficiency versus cost. A living network runs on a simple trade. Keep paths short and resilient, but pay for every bridge. Brains and the cosmic web converge on the same solution. Small world layouts with high local clustering, a few long connections for reach, and minimal total wiring so the system doesn't bankrupt itself. In brains, local neighborhoods handle most computation while a handful of long-range tracks synchronize distant regions. In the cosmos, galaxy groups and clusters do the dense work, while filaments keep separate basins within a few steps. The payoff is speed. The risk is fragility. Long bridges do a lot with a little, so when they thin or misfire, regions drift toward isolation. Wiring cost sets the boundary. The brain is capped by space, energy, and heat. The universe is capped by mass. Only so much baryonic matter can be stretched into filaments after halos claim their share. Every kilogram in a bridge isn't in a star, so corridors stay slender. Voids are huge, highways are thin. Cost forces elegance. Redundancy is selective. Too much everywhere blows the budget. Too little and single failures kill roots. The web sprinkles backups near hubs and junctions, braided filaments that split and rejoin, much like white matter tracks fan into cortical areas as bundles, not single cables. It's a hedge against local catastrophe without paying global rent. Feedback tunes throughput. Galaxies pump energy back into the web, supernovae stirring and venting, active nuclei heating halo gas and sometimes pushing along corridors. Like synaptic weights adjusting with traffic, infall rates, metallicity, and morphology shift with winds and jets. The goal isn't maximum flow, it's sustainable flow. Efficiency under sparse wiring pushes you toward modular clusters with a few long links and toward hubs that shorten paths cheaply, until hubs concentrate load and vulnerability. Brains buffer with layered modularity. The cosmic web buffers with a hierarchy of halos, group, cluster, supercluster, with multiple access roads. If a primary route starves, a secondary spur can keep a trickle alive. Budgets evolve. Gravity thickens nodes, making local paths denser and cheaper. Expansion stretches space, making long paths thinner and more expensive. Strategy shows up as structure. Redundancy stacks near nodes first. Peripheral spans remain single lane. It's triage, written in filaments. And here's the twist that sets up the fall. Small worlds don't fail uniformly, they fracture at bridges. In brains under hypoxia, long-range integration falters before local processing. In the universe under acceleration, intercluster links lose throughput while bound structures persist. Local gravity wins, global connections lose. The rulebook stays, the background changes. Enter the force that taxes every span. The antagonist arrives, dark energy's quiet coup. While the network was optimizing itself, short paths, braided spans, feedback keeping arteries open, something else was changing the background rules. In the late 1990s, two teams led by Saul Perlmutter and by Brian P. Schmidt with Adam G. Rees, looking at Type Ia supernovae, measured how fast distant galaxies recede. Everyone expected a slowdown. Gravity should be tapping the brakes. Instead, the data bent the other way. Far beacons were dimmer than a decelerating universe would allow. Space wasn't coasting, it was speeding up. That pivot gave a name to the quiet force in the ledger, dark energy. Call it vacuum energy, a cosmological constant, or an unknown field. The effect is the same. As the scale factor grows, the average matter density thins, but dark energy keeps the same pressure and energy density. The tug-of-war shifts. Gravity still binds locally, deepening wells, thickening nodes. Meanwhile, expansion stretches the baselines between those nodes at an accelerating rate. Bridges get longer even as they try to carry the same load. Independent lines of evidence agree. Planck's CMB measurements plus bow from SDSS Daisy pin down a flat lambdictum universe with dark energy dominating the recent expansion history. Here's what that looks like when you stand on a filament. Gravity is pulling you downhill toward a cluster. Gas trickles along, sometimes in sheets that roll into threads, but the roadbed space itself lengthens under your feet. At first, inflow wins, you still make progress. Then, over cosmic time, the Hubble flow ramps up between the bigger basins. Past a certain separation, the throughput across the corridor falls. Not because the pipe is sealed, but because the upstream signal, gravity's invitation, no longer outruns the widening gap. It's like two towns on a single-lane causeway as the tide rises. The road is still there. The crossings get rarer, slower, then effectively stop. Stakes move from abstract to personal for galaxies on the margins. Closer to the nodes, redundancy and depth by grace. Farther out, single-lane spurs thin. Once dark energy dominates the energy budget, roughly the last 5 billion years, the balance tilts hard. Intercluster filaments don't snap like ropes, they diet. Their density drops as the background expands. With lower density comes weaker pressure gradients and longer cooling times, so less gas condenses into stars along the route. Starvation spreads from the bridges inward. What was once a two-way supply line becomes a memory of one. You can see the fallout in simulations and surveys that track infall rates and connectivity. Cluster growth continues, but increasingly by eating what's already inside their gravitational reach. The rate at which fresh material crosses the long baselines declines. The giant component of the network, the set of nodes mutually reachable within practical travel times, starts to contract in a useful sense, even if mathematically the graph still exists. That distinction matters. On paper, a path remains. In physics, the clock kills it. Meanwhile, feedback doesn't stop. AGNs still flare, winds still push, but their influence becomes local gardening rather than regional engineering. Jets that once could stir the corridor a few megaparsecs down now mostly shovel their own yard. The same energy budgets that once helped keep lanes open can't compete with the rising toll. The network rulebook remains valid, the price schedule changed. The result is ischemia written in comoving coordinates. Tissues, filaments, starved not by blockage but by distance outpacing delivery. Microstory. Think of a lone spiral galaxy parked near the lip of a filament that feeds a modest group. Early on, it drinks. Cold gas dribbles in, minor mergers spice its disk, new clusters of blue stars dot its arms. Over a few billion years, the stream tapers. The galaxy still shines, still rotates, but the outer reservoir that once fed it retreats past practical reach. It mines its own halo for a while, then turns to older gas recycled by dying stars. The tempo slows. Its future shrinks to what it has on hand. Impact cascades. Isolation grows first between superclusters, then between clusters, later between groups. Local gravity wins hard where it's strong, building thicker, more resilient organs. Global links lose quietly. The small world advantage narrows to neighborhoods. Average path lengths measured by travel time, not just by connectivity, stretch past meaningful. The network doesn't die, it provincializes. There's a temptation to ask for a single timestamp. The moment the coup succeeded. In reality, it's a gradient. But there is a threshold when dark energy becomes the dominant term, after which the direction is set. Paths that might have been maintained with modest mass now demand impossible subsidy. Bridges that would have been repairable under slower expansion degrade into ceremonial spans. From that epoch on, the future belongs to bound sanctuaries and whatever they can hold together. The quiet coup finishes without fanfare. No crack, no shudder, just acceleration turning every span into a longer bet. The antagonist doesn't break the web, it pulls it thin where it matters most. And that's why the next question is whether the universe stays connected. It's how much can be saved inside the organs that refuse to let go. The stroke hypothesis, percolation and the cosmic disconnect. To test whether a network is still one thing, ask if there's a giant component, a sprawling cluster most nodes belong to. Percolation theory says it exists only while a critical fraction of links stay active. Above that, signals cross in a handful of hops. Drop below and the body fractures into islands suddenly. That's the stroke. Translate to the cosmos. Picture nodes, galaxy groups and clusters, tied by filaments whose capacity depends on density and temperature. Let the Hubble flow crank up. As dark energy dominates, space between major nodes stretches faster, corridor density drops, and practical throughput. How much can cross within a Hubble time falls. Links don't vanish, they fall below usefulness. Percolation redefines connection from exists to arrives in time. Stakes for real places. While the giant component holds, metals mix across supercluster scales, outskirts get fed, mergers thread stories together, and radiation fields couple distant neighborhoods. When it fails, those processes stop at each island's shoreline. Inside, uniformity grows. Across islands, diversity fades. Civilizations needing exchange across tens of megaparsecs watch hard, become impossible on cosmological timescales. The critical point in a lumpy living universe isn't tidy, so simulations did the lifting. Grow a lambdictum universe, millennium, illustris TNG, trace filaments, measure link densities and travel times versus redshift. The key hint lands around Z051 when dark energy starts to run the budget. Infall from long-range reservoirs declines sharply, filament gas heats and rarefies, cooling times lengthen, and parcels crossing the longest spans rarely condense and deliver. Star-forming galaxies show reduced cross-filament synchronization as environments decouple. No single blow, just roots fading below functional thresholds almost everywhere at once. At supercluster scales, the giant component defined by reachable within an epoch collapses into bound basins. Inside each, paths stay short and dense. Between them, path length measured in years diverges. A line may exist on a map, but the cost to traverse it exceeds any physical budget. In percolation terms, the occupation probability of effective links fell below critical. The spanning cluster is gone. Early time percolation during reionization was bubbles of transparency touching so light could run. Late time percolation is its mirror, bubbles of inevitability, bound regions, becoming the only places where exchange stays real. The web becomes a jar of organs, each stable, each aging on its own clock. Observables track the shift. Cluster mass growth pivots from smooth accretion to mergers of already bound halos. Clear filamentary inflow signatures decline. Metallicity gradients flatten locally and diverge globally. Galaxy alignments with parent filaments weaken at the largest scales as distant torques decouple. Same symptom, different instruments. The orchestra lost its conductor because sound can't reach the back row. Don't circle a single day. Think an epoch when the last trans-island spans slip under. Some reconstructions place the practical threshold near when dark energy dominates. Stricter, deliverable definitions push it later. Either way, the arrow points one way. Past that window, no routing restores a giant component across cosmic scales. The universe keeps a web on paper and loses a web in practice. Microstory. Across a supercluster bridge that once carried dwarf groups toward a rich node, a final trickle of cold gas drifts, stretched, heated, and bled thin by the ride. It reaches the midpoint and fails to cool. No stars will light that causeway again. Both ends keep living, even thriving, but they'll never share a season. That's the pivot downstream. If stroke equals disconnection, the next system to suffer is memory. The lived history a network writes by mixing, feeding, and exchanging. The ledger turns local. The archive fragments. The universe won't go dark tonight. It will forget how to talk to itself. Memory in a universe, how the cosmos remembers. If disconnection is the stroke, memory is what fades next. Not memory like ours, but the ways the universe records its own past. Every galaxy keeps a diary in matter and light. Read it right, and you can hear the episodes. Who fed whom, who collided, who went hungry for 1 billion years and then finally ate. Start with metals. Stars forge heavy elements and scatter them. The pattern they leave, metallicity, maps the meals. Cores of big galaxies are rich because they've been fed, stirred, and refed. Outskirts are poorer when supply lines are thin. Stretch that across a filament and you catch the ghost of trade. Gradients smoothed by exchange, sharp edges where traffic died. Metallicity is memory ink, diluted by mixing, deepened by bursts, frozen by isolation. Stellar populations tell time more bluntly. Old, red, alpha-enhanced stars mark fast early feasts. Young, blue clusters flag recent deliveries. Stack a galaxy's stars by age and chemistry, and you get a barcode of its inflows, outflows, and close calls. Quench a corridor and late arrivals vanish from the record. The barcode ends with a long, quiet band. Black holes keep more private notes, but they're legible. A supermassive black hole's mass and spin encode the tempo of accretion and the violence of mergers. Long, calm feeding leaves a different imprint than a chaotic sequence of random snacks. A line spins and you've likely got a history of steady inflow along a preferred axis, often set by a filament. Scramble them, and you're reading a life lived at junctions, where directions change and partners arrive from every angle. Then there are the structures that act like file systems. Streams, thin rivers of stars stripped from dwarfs, wrap halos in looping cursive. Their thickness, coherence, and chemical tags remember the orbits of the accreted and the gravity they felt. Shells mark radial collisions. Warps whisper about torques from neighbors you might not see anymore. Even the shapes of disks, barred, flocculent, grand design, depend on supply rhythms and perturbations. Morphology is the short story. Kinematics is the underlined passage that tells you why. Entropy is the background ledger. Hot, well-mixed gas at cluster centers is high entropy, the end of many stirrings. Low-entropy pockets trapped along filaments signal cooler inflows not yet erased by shocks. Map entropy in X-rays, and you trace which routes stayed open. Watch those pockets fade as distances win, and you're watching the archive compress into sameness. The cosmic microwave background holds the prologue, tiny temperature ripples, polarized patterns that record the first sound waves. On smaller scales, the Sunny Zeldovich effect adds late notes, hot gas scattering CMB photons, announcing that clusters formed here at this time with this pressure. Stack enough clusters, and the SZ statistics become a census of late heating, the universe's marginalia. Isolation edits all of this. Cut off fresh gas and star formation skews old and metal-rich, not because the universe ran out of atoms, but because recycling dominates. Dying stars return material to the interstellar medium, but it's tired fuel, enriched, often warm, slow to cool. Without outside dilution and pressure, the next generation looks like the last, only dimmer. Diversity shrinks. The plot narrows to epilogues. Microstory. A starving dwarf at the end of a fading spur carries two tales in its body. The first, a burst of blue a long time ago when a wave of metals from upstream finally reached it, triggered cooling it couldn't do alone. The second, a gentle, stubborn trickle of red giants forming from recycled gas, century after century on cosmic scales, because nothing new ever arrived again. Its spectrum is a farewell letter written in two inks. Memory also lives in alignments and spins. Galaxies tend to point and rotate with respect to their parent filaments in ways that reflect early angular momentum transfers. That coherence is a fossil of tides from large structures. As links stretch and weaken, new torques fail to synchronize distant neighborhoods. The old alignments persist inside islands. The cross-island choir drifts out of tune because no conductor's downbeat reaches across the gap in time. Even the statistics of mergers mutate. When the giant component was lively, minor mergers streamed in along many directions and the catalog of orbits was varied. In isolation, the supply becomes whatever was bound already, satellites on fixed families of paths. The future's archive gets repetitive. Fewer rare events, more echoes. Zoom out and you notice something sobering. Information in the thermodynamic sense, tends toward erasure as systems thermalize. But structural information, arrangements, gradients, and isotropies, can persist for a long time if you stop stirring. Isolation paradoxically preserves some chapters by sealing them, while erasing the library's cross-references. You can still read a galaxy's past within its halo. You just lose the paragraphs that connect it to a neighbor's fate. This is why percolation mattered so much. While bridges carried influence, the cosmos wrote a collaborative book. After the threshold, every island writes a memoir, beautiful, detailed, and incomplete. And if you care about consciousness riding inside any of these structures, that narrowing isn't abstract. It constrains futures. It confines meaning to local shelves. The universe keeps remembering, just less of each other. Consciousness on borrowed time. So where does that leave thinking things, us, nested inside this fading web? Start with a simple stack. Neurons form brains, brains build societies, societies build infrastructures that stretch across star systems, all nested inside galaxies braided by filaments. It's networks all the way up and down. When the macro network thins, everything inside it inherits the constraint. Ambition becomes a geography problem. Civilizations live on logistics, not poetry supply lines. Interstellar projects need propellant, metals, energy beaming, time coordination, and redundancy. Intergalactic projects multiply that by distances that punish every inefficiency. While the giant component held in practice, there was room to dream big. Harvest gas-rich dwarfs, skim cold flows, trade elements across neighborhoods, map and mix. As those links slip under the percolation threshold in usable time, the menu shrinks. Not to nothing, but to local. Here's the catch people gloss over when they imagine Dyson swarms and Kardashev climbs forever. Horizons aren't metaphors, they're rules. As space accelerates, the event horizon tightens around what will ever be able to talk to us. Resources beyond a certain radius are, for our purposes, already gone. The expansion doesn't steal atoms from us, it steals coordination. That difference sounds academic until you run a mission plan and the signal you need can't arrive before the clock runs out. The window is not static. Every million years you wait, less is reachable and the penalty compounds. Early action is the discount. Delay is a tax you can't repay. From the inside of a brain, this looks familiar. Starved tissue and the system prioritizes. The cortex stops playing symphonies, it protects the core. Awareness narrows, then fragments. Meanwhile, local circuits keep firing a while, reflexes, habits, the automatic. Translate that to a civilization under receding reach. Exploration budgets fall to maintenance. Maintenance falls to triage. Triage falls to what can be closed, recycled, and defended. It isn't collapse by drama, it's narrowing. That narrowing doesn't have to be nihilism. It can become strategy if you treat windowed time as policy. The near future is uniquely rich. Corridors still carry, though thinner. Some dwarfs are still catchable. Some intergroup paths still deliver if you move now. There's a duty embedded in that window. Act while the physics still offers leverage. Build the redundancies your descendants will need when redundancy costs more. What does action look like beyond slogans? First, get honest about scale. For the next few million years, interstellar is the frontier that pays. Local capture of errant comets and dwarfs, reprocessing of halo gas via cooling catalysts, aggressive solar output management to stretch star-facing budgets, energy beaming networks to unify a system's scattered harvesters. These are network repairs inside the organ that is your galaxy, not fantasies about pulling down a cluster. Second, lean into diversity as an existential hedge. Isolated islands trend towards sameness. Sameness is fragile. Curate stellar populations the way farmers rotate crops. Seed long-lived red dwarf systems with biospheres and archives because they're time-rich. Keep a few blue giants around as industrial furnaces for the rare jobs only they can do. Store knowledge in multiple carriers. Biology, hardware, crystals, encoded matter, because failure modes are correlated. Culture isn't decoration, it's error correction. Third, treat velocity like a currency. The earlier you move, the cheaper distance is. That applies to matter and to meaning. Send probes, yes, but send factories. Send seeders that can bootstrap infrastructure from raw ice and dust. Aim them along corridors that still flow, even weakly. A weak current beats vacuum. Every decade you wait raises the toll. There's a human angle that bites harder than any budget. Connection as meaning. For a century, we've wrapped hope around the idea that the universe is teeming, and that someday we'll meet the others who solve the same problems. Horizons don't declare we're alone. They say we may never know. So you build a culture that can thrive without that promise. You teach children that stewardship isn't small, that making one island abundant, kind, and wise is a heroic scope. You give them stories that honor both reach and roots. Ethics shifts under scarcity of reach. The loud temptations are domination and despair. The useful virtues are patience, completeness, and mercy for successors. Patience to build projects that mature after you're gone. Completeness to document not just triumphs but failures, so someone else doesn't repeat your dead ends when contact is impossible. Mercy because your descendants will inherit constraints you helped set. Leave them options, not debts. Get this, biology already rehearsed this. Life evolved in tide pools before it learned oceans. It hoarded, recycled, diversified, and rebuilt under constraint, then scaled when paths opened. We're the cognitive expression of that rhythm. The universe is moving from ocean to tide pools again. Our job isn't to curse the tide. It's to design pools that endure, exchange within reach, and keep embers lit for as long as physics allows. Microstory. A civilization ringed a quiet red star with a loose lattice of collectors and farms. On the far side of their system, they kept a factory asleep inside an icy dwarf, fueled by trickles from a beamed grid. Once a century, the factory woke and printed a courier, small, slow, hard to notice. Each carried a library cut to bone and a kit for making a relay if it ever found a friendly harbor. Most couriers would drift forever. A few, launched early, would cross a corridor in time. They knew that, they launched anyway. Meaning compresses when horizons close, but it doesn't vanish. It localizes, it deepens. Consciousness rides networks, and our network still has room to build. The window is closing, it's also open. The counterforce, gravity's last safe havens. If acceleration is starving the bridges, gravity is quietly fortifying the organs. Bound structures, galaxy groups and clusters, don't care about the Hubble flow inside their walls. Their escape speeds beat expansion locally, so matter that crosses the boundary stays. In a thinning web, that makes them sanctuaries, places where complexity can keep breathing because the supplies can be corralled, recycled, and defended. Think of a modest group like the local group. The Milky Way and Andromeda are on a collision course not because expansion paused, but because their mutual gravity already won. Over a few billion years, they'll merge, pooling stars, gas, and dark matter into a deeper well. Do that across the sky and you get a motif. Islands consolidating their coastlines, pulling in loose satellites, sweeping their neighborhoods clean. It isn't predation, it's preservation by capture. Inside clusters, this consolidation runs hotter and louder. Hundreds to thousands of galaxies swim in a common halo, soaked in X-ray bright gas. The intracluster medium is a warehouse and a furnace, a vast reservoir of baryons, metals, dust grains, and magnetic fields. Gravity keeps it bound. Shocks and turbulence keep it mixed. That mix has a cost. High temperatures make cooling hard, but it also sets up a long game. Even trickles that cool from the halo can seed future stars if you manage the heating. That if is where strategy lies. Action looks like infrastructure. Build where gravity discounts the bill. Cluster cores are already dense. You can sink collectors into orbits that skim the hot gas, harvest its heat with thermodynamic engines, and dump waste back into the same reservoir without losing it to the void. You can erect mirrors and maser chains to shepherd energy between member systems, turning a cluster into a beamed grid commons. Redundancy comes free with orbits. Thousands of stable paths, many crosslinks, no single point of failure. Groups do a gentler version. Their halos are cooler. Their galaxies still have cold gas. That's an opening for assembly. You capture the dwarfs now, before their orbits decay, before they drift outward across a corridor that won't deliver them back. You stabilize unstable triples with tethers and momentum exchange, so merging events happen under supervision rather than as random wrecks. You park volatile resources, icy bodies, molecular clouds, in pseudo-Lagrange corral orbits where perturbations are small. You're building pantry space. Stakes are simple. If you don't consolidate locally while routes still work, you lose both the distant supplies and the nearby strays. A star-forming dwarf just outside a group's virial radius today is a neighbor. A billion years from now, without help, it's a postcard you'll never receive. With help, gentle propulsion nudges, beamed sails, gravity assists through the group's outskirts. You can drift it inside the safe well. The earlier the push, the cheaper the rescue. Clusters offer another gift, time dilation of change, not of clocks. Inside a deep potential, orbits process and mix, but the inventory doesn't evaporate. Metals ejected by wind stay in the family. Stripped gas finds its way into the shared pool. Stars lost from galaxies light the intracluster space as a faint glow you can bank on. That's a closed economy in the best sense. Losses become resources elsewhere in the organ. Preserve diversity sounds like a slogan until you run the physics. Long-term star formation needs varied fuel, pristine streams for balance, enriched gas for rapid cooling, dense clouds for bursts. Left alone, isolation pushes systems toward homogeneity, hot, metal-rich, quiescent. Inside safe havens, you can curate. Keep a catalog of stellar populations at different metallicities. Seed long-lived red dwarf systems with worlds and archives. Maintain a few starburst nurseries to refresh the isotope pantry. Diversity buffers against unknowns because every path to complexity has a different diet. Microstory. In a small cluster, a coalition of worlds around a sun-like star, and a red dwarf builds an orbital yard at the edge of the central galaxy's halo. They tug 3 gas-rich dwarfs inward over 5 million years with phased laser sails, too slow for thrillers, perfect for physics. Each arrival is dismantled carefully. Some stars are left alone, their planets surveyed. The gas is cooled into dense reservoirs. Rare elements are tagged and shelved. The intracluster glow brightens a notch. The pantry grows. Feedback becomes a tool rather than a hazard when you're playing defense. You don't quench galaxies indiscriminately. You time heating to suppress only runaway cooling that would trap gas in unhelpful phases. You trigger gentle, AGN-like outbursts with beamed energy when filaments feeding the core start to overdeliver metals, keeping the medium in the sweet spot where pockets can condense later. It's not weather control, it's irrigation. What nobody realized at first, when acceleration was a curiosity and clusters were just bright dots, was that these wells aren't merely endpoints, they're life support systems. They're the only places where the balance of binding energy against expansion lets you run long projects with guaranteed returns. Outside, every plan pays a distance tax that rises with time. Inside, gravity subsidizes patience. There's a catch. Make the organ too sealed and you smother future options. Overheating the core shuts down cooling catastrophes, but it also locks gas in a sterile phase for gigayears. Overbuilding megastructures around a single star maximizes short-term harvest but creates brittle failure modes. The safe haven has to be a small world too, tight local loops, multiple pathways, spare bridges, and gentle load balancing. Don't build a monolith, build a mesh. Safe doesn't mean still. While corridors exist, you keep tugging, capturing, and cataloging. You lay down relay constellations across the group so messages and energy reroute when a node fails. You preposition manufacturing in many orbits so no single crash kills an industry. You teach every settlement to operate dark, autonomous for long stretches, because outages are training for a future where the outage is forever. Meanwhile, unknown to most who never look up from their planets across other towns in the sky, parallel sanctuaries are doing the same. They'll never meet. They don't need to for the strategy to work. Each organ learns to breathe on its own schedule with gravity as its ventilator. The web is failing between them. Inside, the work continues. Cosmic bypass, rerouting the failing web. If the arteries are thinning, you don't surrender, you reroute. In medicine, a bypass graft feeds tissue downstream of a blockage. In a fading cosmos, the idea scales. Engineer new corridors, nurse old ones, and push matter and energy where gravity alone can't. Start with what's possible now, not in fantasy centuries. Filaments are real structures. Low-density gas, magnetic fields, trace dust, and drifting dwarfs threaded between groups. They're weak, not empty. A civilization with focused power can tip them. Think beamed energy networks stitched across a group, phased like a choir. You aim power at a strand's coolest pockets, nudging temperatures and ionization so radiative cooling wins. Cooler gas condenses into clumps. Clumps pull more gas. You're thickening a lane, one cooled pocket at a time. Seeding stellar nurseries is the second lever. Early galaxies got help when metals made cooling easier. You can do that on purpose. Launch slow freighters, shoebox factories wrapped in ablative ice loaded with dust grains and catalytic molecules. They park in underfed segments, shed a glitter of seeds, and wait in the dark while weak currents do their work. When density peaks, you ignite star formation in planned bursts, not fireworks everywhere. The goal isn't spectacle. It's supply lines. Small suns placed like mile markers to light, heat, and slowly pump momentum into the corridor. Meanwhile, copy what AGN do, minus the collateral damage. Jets from black holes stir and channel gas, but they're wasteful and indiscriminate. With beamed microwaves or lasers, you can shape gentler collimated flows along existing magnetic scaffolds. Magnetohydrodynamics stops being jargon when you ride it. Align fields, lower effective viscosity, nudge pressure gradients. Over millennia, a trickle becomes a brook you can count on. It sounds slow because it is. That's the point. You're buying centuries of throughput in a universe where waiting pays. Toolsets converge on one theme: distributed intent. Beamed power relays that pass a baton when alignment slips. Autonomous shepherds the size of asteroids that station keep in currents like kelp, redirecting drifts by throwing their mass around with reaction wheels and magnetic sails. Arrays that sense density ripples and retune, like synapses adjusting gain. The corridor becomes a networked project, not a single pipe. Stakes are brutal if you fail. Lock-in arrives. Islands freeze into whatever they manage to bottle. Without bypasses, some groups starve early, their dwarfs quench, their chemistry stalls. Diversity narrows, and with it the range of futures. With bypass, you cheat the curve. You're not overturning horizons, you're stretching reachable resources through the last cooperative years. Impact isn't just matter moving, it's time. Extend star-forming epochs, and you extend the window for biology, culture, and experiment. You maintain metabolic diversity across a cluster's economy. Cold gas for gentle growth, hot reservoirs for industry, ionized lanes for communication relays. You keep the organ metabolically flexible as the body forgets. Here's a micro-story from the edge of usefulness. Two dying nodes, a loose group and a poorer neighbor, stare at each other across a thinning thread. A coalition in the richer group spends 3,000 years building a beamed corridor, phased mirrors strung in Trojan swarms, maser farms anchored to brown dwarfs, a chain of quiet relays tuned to the lane's natural modes. On the other side, the poorer group sends shepherds, slow, silent tugs toward the midpoint. They meet in the cold, aligned fields, and the lane brightens by a few percent. It's enough. One last convoy of gas-rich dwarfs crosses in 100 million years. When the relays finally fall dark, both sides have more time than they would have had. One last exchange, bought by patience. Skeptics ask the hard question: why spend effort on cross-group lifelines when cluster cores look like destiny? Because cores aren't the only organs worth saving, and centralized bets fail hard. Bypasses diversify the portfolio. They let midweight groups avoid being strip-mined by neighbors. They keep rare isotopes and odd stellar populations in circulation. They buy options against unknowns that cluster environments might kill. There's another benefit: practice. Rerouting teaches a culture to think like a network surgeon. You learn to read density, to coordinate across light hours and light years, to accept projects that mature after your lifetime. That skill set translates when horizons close and only local meshes remain. Bypass work is rehearsal for graceful isolation. None of this violates the ledger we've been keeping. You're not canceling acceleration. You're exploiting the last leverage physics offers, the asymmetry between acting early and acting late. Early, a few megawatts at the right place can redirect a river. Late, a sun's worth of push won't move a droplet. The universe writes that inequality into every plan. That asymmetry is ticking now. If you intend to seed corridors or capture strays, starting in this epoch is the only bargain you'll ever get. One caution matters. Corridors are ecosystems. Overdrive them and you trigger heat that lengthens cooling times. Underdrive them and the project never percolates. The art is dosing, pulses that avoid shocks, seeding that avoids over-enrichment, routing that respects the lane's natural resonances. Think irrigation, not dams, mycelial networks, not freeways. When it works, the payoff isn't a triumphant bridge glowing across the void. It's quieter. A catalog entry changes from unreachable to hard but possible in time. A dwarf arrives inside a group's well 100 million years earlier than it would have, early enough to matter. A filament that would have gone dark in 5 gig-years fades in 7 instead. 2 billion extra winters of star formation across 1,000 worlds is not a headline. It's a civilization. The prison of horizons, when out there, vanishes. Here's where the ledger stops caring about optimism and starts enforcing physics. Horizons aren't lines on a map. They're limits on cause and effect. 3 of them matter for anyone trying to keep a network alive. The particle horizon is the record of what's ever been able to reach us since the beginning, our observable past. The event horizon is worse news. It's the frontier beyond which events happening now will never influence us, no matter how long we wait. The cosmological horizon, set by expansion, moves the goalposts as the scale factor grows. While corridors still carry, those distinctions feel academic. Then acceleration turns them into strategy. The particle horizon keeps expanding. We see more of the ancient past as light finally arrives. But the event horizon tightens the future. There are galaxies we can photograph today that no signal we send will ever touch. Their light is inbound from older times. Their present and ours are already causally divorced. That's not poetry. That's a permanent no from physics. Action compresses into what can still answer back. Plans involving rendezvous with distant groups fail first, not from engineering shortfall but from causality. You can push a probe to a fraction of light speed, stack beaming arrays, build relays in every corridor, and the math still kills it if the destination sits beyond the event horizon measured from your clock. The signal you need, the receipt, the handshake, the control, can't make the return trip. Mission profiles flip from go and coordinate to go commit and never expect a reply. Stakes turn psychological as much as logistical. Whole branches of meaning leaned on the hope that out there was reachable if we got clever. Horizons force a switch to local completeness. You design cultures that don't require confirmation from beyond the line. You build redundancy until it feels excessive, because there won't be last-minute rescues from neighbors you can no longer hail. Archives become lifeboats, not advertisements. Impact lands in the shapes of institutions. Research agendas tilt toward what your island can test. Engineering focuses on systems that can be maintained with local isotopes, local catalysts, local weather. Education changes tone. You teach orbital mechanics and materials science with the same seriousness you once reserved for first contact protocols. Philosophy gets honest about the difference between loneliness and independence. Loneliness asks for company. Independence asks for competence. The human angle bites quietly. People don't mourn horizons, they mourn possibilities. So you give them projects that dignify the boundary. Build a complete atlas of your island, star by star, comet by comet, orbit by orbit. Map your halos, streams, and fossils so the next 10,000 years of science have raw material to mine. Seed evergreen sciences that don't need new sky to thrive. mathematics, condensed matter, synthetic biology tuned to local elements. Purpose survives because craft survives. Meanwhile, communication strategies adapt to one-way futures. You still beam messages outward, but you treat them as bottles. Compress aggressively. Repeat rarely, but for centuries. Stack error correction inside error correction. Read Solomon on top of low-density parity, interleaved with checksums woven into myths and music, because sometimes the receiver will be a culture, not a decoder. Accept that acknowledgments may never arrive. Measure success by the rigor of what you sent, not by the ping. Inside the island, horizons are practice, not prison. Event horizons shrink the set of partners, they don't shrink curiosity. So you redirect exploration downward and inward. Oceans, mantles, tokamaks tuned to new regimes, quantum limits you can reach on a lab bench. You build colliders sized for your economy, not your dreams, and you squeeze their data dry. You excel at feedback, closed-loop ecologies, closed-loop manufacturing, closed-loop knowledge, because every loop you close buys another century of slack. There's a grief you don't dodge. The map once felt like a web with an address for everyone. It becomes an archipelago. The trick is to make the island a world, not a bunker. Worlds have festivals, archives, rival schools of thought. Bunkers have inventories. Choose the first on purpose. Culture is infrastructure as surely as power is. Songs and rituals carry memory through low points when textbooks fail. Myths encode heuristics, rotate crops, keep redundant clocks, tell the truth about failure, so skills survive fashion. What nobody knew, when acceleration was a curiosity and horizons were lecture hall diagrams, was how adaptable meaning can be when the field narrows. It turns out constraint is a teacher. When out there vanishes as a plan, in here sharpens. We get careful with definitions, generous with apprenticeships, meticulous with logs. We write in plain language because we want to be understood by people who won't share our assumptions. We build languages that survive drift. We carve on stone, etch in diamond, fold into DNA, and teach by story. And we listen, because horizons don't silence the past. Light still arrives from galaxies already gone beyond contact. Each photon is a late letter from a neighbor we'll never meet. You can treat that as a taunt or a gift. We choose gift. We read the skies as an archive, not a frontier. We learn from dead bridges how to tend the living ones. We stop asking the universe to stay young for our convenience. We grow up inside the island we saved. Encoding the universe. Last messages in a dimming network. When horizons turn partnerships into one-way streets, the last thing you can trade is information. Matter stays, meaning moves if you can afford the cost. Thermodynamics sets the price. Landwehr's line in the sand says erasing a bit has a heat toll. Storing it can be cheaper if you're careful. The colder your substrate, the slower your clock, the less you pay to hold a thought. In a dimming network, you stop broadcasting noise and start engraving memory. Compression becomes survival craft, not brute zip files, semantic compaction. You strip redundancy, then add it back in patterns that can outlive your power grid. Error correction codes nested like Russian dolls. Interleave the same sentence in multiple alphabets, then bind that sentence to a recipe someone can reconstruct with rocks and patience. You're not optimizing for elegance. You're optimizing for recovery by strangers who might be your own grandchildren in a language you never taught them. The substrates matter as much as the message. Hot silicon won't last. You need media that shrug at radiation and time. Degenerate matter is a mouthful, but neutron stars are too intense and too far. Closer to home, dense, cold crystals, diamond, silicon carbide, can lock in dopant patterns for millions of years if kept out of heat. You can write three-dimensional holographic codes into them. Colors, orientations, vacancy lattices, maps inside maps. Put them in vaults where geologic churn is slow and predictable. Redundancy isn't 3 copies. It's 3,000, scattered from inner moons to halo rubble. Then there's the unfriendliest library, black holes. They look like shredders, but if you feed them right, they're vaults with a thermostat. At the edge, the horizon, the temperature drops as the hole grows. Big holes are cold. The Hawking trickle is slow. If you encode in the infall, modulate the accretion with precise timing and composition, you inscribe a boundary condition that, in principle, leaks back as radiation over absurd times. That's not a practical channel for conversation. It's a bet that physical law is consistent enough that future minds can invert a long, faint whisper. It's the ultimate time capsule. It also courts controversy. Not everyone agrees you can read the ink cleanly. So you don't put your only copy there. You diversify. A cheaper, nearer trick is to mine holes for power while you write. Penrose and Blandford, Xenagic aren't bedtime stories. They're blueprints. Extract spin energy, drive beam systems, power a lattice of archival foundries in safe orbits. Every joule you don't waste on heat you spend on checksums. Every checksum you compute you bury in a different medium. Redundancy is a budget line, not an afterthought. Language is the next trap. We're trained to think in alphabets that require a Rosetta to decode. You need something harder to kill, math and physics tied to local sky. Build your codebook in layers. First layer, prime spirals, spectral lines, orbital periods of nearby pulsars, chemical fingerprints of your own star. Second layer, constructions, how to build a clock, a lens, a sensor to read the rest. Third layer, content, biology, histories, engineering tricks that don't assume your metals, your plants, your myths. Fourth layer, seeds, self-checking curricula that teach the codebook itself to a mind that didn't evolve like ours. Don't write a monument, write a teacher. Placement is politics. You want archives everywhere, but some places last. Cold trap craters on airless moons. Trojan swarms that drift but don't collide much. Quiescent dwarf planets far from tugs. Oort cloud chunks stabilized with tiny engines that maintain slow, boring orbits. Inside clusters, park libraries in intracluster space, free-floating, tethered to nothing but subtle thrusters, so no single galaxy's bad day erases your work. Put decoys and decoys for the decoys, because entropy has minions called curiosity and war. Now practice the 30-second rule on your own plan. Would someone keep watching in 10,000 years? If not, add a human moment to the archive. Songs with built-in math, myths with orbital mechanics in the plot, stories that reward decoding with useful knowledge. You don't know the readers, you can still make them care. Microstory. A quiet shop in the shadow of a tidally locked moon prints a crystal the size of a thumb. Inside it, a lattice of vacancies spells out a map of local pulsars, a recipe for growing seed crops in poor nitrogen, and a simple beam steering array you can build with rocks and patience. The shop seals it in a nickel iron shell and shoves it gently into an orbit that will be boring for 1,000,000 years. Across the cluster, other shops do the same. No ribbon cutting, just persistence. What nobody expected back when we treated archives like museums is that information can outlast stars if you stop insisting it shimmer. Cold beats fast, dense beats flashy, local beats global when global is gone. And compression isn't about making it small, it's about making it inevitable that someone can make it large again. The network is dimming. The answer is to write brighter in slow ink. Not to scream into the dark, but to embed a map of how to build a voice. Then scatter voices everywhere and let gravity keep them. Why the universe looks like a brain, and what that doesn't mean. Hold the side-by-side images in your head for a second. Neurons branching in gray matter, galaxies threaded through black space. The likeness is real enough to make you pause, but here's the boundary we have to respect. Shared shapes don't make shared minds. The resemblance comes from constraints, not a cosmic self. Start with what's actually measured. In both systems you see heavy clustering, dense neighborhoods, and short average path lengths thanks to a few strategic bridges. Degree distributions are skewed. Many low-degree nodes, a sprinkling of hubs. Hierarchies stack, dendrite to track to region, dwarf to filament to cluster. Run network metrics and you get overlapping orders of magnitude for clustering coefficients and modularity. It's the small world recipe showing up twice because the ingredients, efficiency under sparse wiring, push design toward the same minimums. Why convergence? cost and performance. The brain's ledger counts energy and space. It can't heat itself into a seizure by laying useless axons. The universe's ledger counts mass and expansion. It can't afford to smear baryons everywhere when gravity needs them concentrated. Optimize short paths with minimal cable, and you're pulled toward bundles, hubs, and long links you use sparingly. That's how nature dodges bankruptcy in two very different economies. Now the limits. Brains learn by changing synaptic weights with spikes in chemistry on millisecond scales. The cosmic web changes by moving matter on gigayear scales under gravity and feedback. One is a communication network designed by evolution to integrate information. The other is a transport network emergent from fluctuations and collapse. There's no cosmic cortex, no global workspace, no place where it all comes together and decides. The signal along filaments is gas and galaxies falling, not thoughts. The universe doesn't integrate meaning across its web. It just moves stuff. That's not a buzzkill, it's clarity that keeps us from drawing wild conclusions. It stops us from declaring panpsychism because two pictures rhyme, and it keeps us from designing policy around metaphors. You can use the analogy to spot dynamics, vulnerability at bridges, resilience in modularity, percolation thresholds that shatter giants into islands, without pretending the cosmos is sentient. The map is useful, the poetry is optional. There's also a trap in hub worship. Hubs shorten paths, sure, but in brains they're buffered by layers of modularity and plasticity that reroute on the fly. In the cosmic web, hubs are gravitational wells that deepen and sometimes starve their outskirts. Knock out a cortical tract, nearby tissue can often rewire. Thin a filament, there may be no substitute. Similar topology doesn't guarantee similar failure modes or fixes. That's why our bypass ideas had to be gentle irrigation, not synaptic surgery. Here's a cleaner way to hold the likeness without overreach. Treat both as outcomes of a rule. When you've got to do a lot with a little, you build small worlds. Brains do it to compute fast without burning up. The universe does it to move mass efficiently without wasting baryons. Then the differences explain the stakes. A brain's purpose, if you allow that word, is to integrate signals into behavior. A cosmic web's purpose, if it has one, is just physics unfolding. Meaning emerges locally inside it. Minds, cultures, projects riding the flows. But there's no cosmic executive. What nobody knew until images and simulations got good was how far the quantitative echo would go. Power spectra of fluctuations, void fractions, clustering stats. Turns out you can put numbers on the gut feeling that the two look alike. But those numbers live inside error bars, and they're apples and oranges underneath. Brain slices are approximated with proximity graphs. The cosmic web is traced by galaxies and dark matter skeletons. You compare because it's instructive, not because it's one-to-one. So what do we do with the analogy? Use it to sharpen survival instincts. Brains tell us that long bridges fail first under stress. We recognize that in the thinning filaments. Percolation tells us that connectivity isn't a slow fade. We saw the stroke as a threshold. Small world math tells us to balance redundancy with cost. We aimed strategies at braided lanes and cluster meshes. The metaphor guided tactics. It didn't crown a cosmic mind. Micro story. A researcher who loved the symmetry once drafted a paper arguing for a global self of the universe. The math was elegant, the images were stunning. Then she ran the timescales and energy budgets. Milliseconds versus eons. Watts per kilogram versus whispers per megaparsec. She rewrote the paper. Same plots, different claim, convergent architectures under shared constraints. The elegance stayed, the overreach didn't. There's a deeper kindness in drawing the line. If you stop asking the universe to be a brain, you free actual brains to act. You keep your ethics grounded in lives you can touch and your engineering grounded in lanes you can thicken. You build meaning where meaning works, in islands that still answer back. And when you look up at the web that resembles a thought, you read it as invitation, not identity. It's not a mind, it's a habitat. Use the likeness to see its rulebook, and then write your own. Living well in a fading web. If the cosmos is shifting from a conversation to a memoir, living well means writing the chapters that still matter. Values get practical fast. Stewardship over conquest, completeness over spectacle, kindness to successors you might never meet. Not because it's noble, but because it works when reach diminishes. The line between elegy and blueprint is thin. We aim for both, but the blueprint has to carry more weight. Start with reversible choices. Hard-to-undo projects, single-star enclosures, monoculture power grids, one-language archives, by short-term gains and long-term brittleness. Reversible design keeps option value alive. Build meshes instead of monoliths. Modular habitats, swappable power nodes, interoperable standards that accept drift. Design supply chains that can run backward when a component fails, so salvage becomes a feature, not a crisis. Next, preserve diversity like you preserve soil. In star systems, that means tending a spectrum of stellar environments. Modest swarms around K and M dwarfs for longevity, compact harvesters around hotter stars for heavy industry. Quiet reserves in asteroid belts for materials that don't like heat. In biology, it means polycultures, ecosystems tuned to different gravity, light, and chemistry, so failure modes don't sink. In culture, it means languages and traditions that encode different heuristics for risk, repair, and patience. Redundancy across difference is resilience. Teach future-proof skills. Not a canon of facts that go stale, but crafts that survive supply shocks, orbital navigation with poor clocks, metallurgy with weak flux, chemistry that leans on abundant elements, agriculture that tolerates bad seasons. Codify the recipes inside stories that travel, fables about counting primes with knotted cords, myths where heroes repair broken rings by listening to their procession. Story isn't fluff, it's error correction carried by memory. Then there's the ethic of kindness to successors. We're used to thinking of legacy as monuments. Shift that to options. Leave them working minds that aren't strip-scarred, cooling ponds that aren't toxic, catalogs that list not only how we did things but why we stopped when we did. Add footnotes on mistakes. Make it easy to recover from us. Meanwhile, run civilization like a network whose links are aging. Prioritize local completeness, food, energy, medicine, computation. Then layer outward carefully. Build beamed energy rings that can pass power when storms take a node down. Cache seeds and tools in boring orbits so rescue kits arrive even if the sender never hears back. Practice bad news drills as festivals, where communities rehearse dark grid seasons under lantern laws and come out stronger, not scared. Use time asymmetry. Horizon physics pays early movers, so move early on low-velocity captures. Shepherd icy bodies into stable hoppers. Nudge neighbor dwarfs if you can catch them. Seed long-range couriers while corridors still carry. Don't glamorize speed, glamorize lead time. A 5-degree correction done now beats a 1,000-degree burn later. Give meaning a shape that fits the island. Curate a complete atlas of your sky and ground, because completeness is an act of care when new data won't come fast. Fund evergreen science that deepens regardless of new vistas, mathematics, logic, materials, control theory. Then apply it to maintenance as if maintenance were exploration. Build rights that honor repair. A day each year when cities disassemble one machine and reassemble it better, with a new apprentice leading. Keep an eye on grace. Elegy has a pull, so does bravado. Neither keeps lights on. Grace looks like communities that celebrate quiet wins, a cooling loop that runs a decade without leaks, a school that graduates students fluent in 2 crafts and a song, a ship that departs on a one-way mission with a full library and a clear goodbye. Grace has a schedule and a ledger, and it smiles anyway. Plant the final loop now. Flatline never meant silence everywhere, only silence between islands. Inside each sanctuary, the web still speaks. Your job is to keep voices in harmony without needing a conductor. A cluster becomes a choir when each section can carry the piece if the others fall quiet. That's not apocalypse. That's music theory for civilizations. So we close this chapter with a practical creed. Do work your grandchildren will thank you for even if they never say it. Write instructions a stranger can follow without knowing your metaphors. Store kindness in systems that survive boredom. Treat time as a terrain with slopes you can still descend. Live well by leaving options, not orders. The last signal between islands. The universe won't end with a bang. It'll thin into islands that keep talking to themselves and forget each other's names. The choices that matter most are front-loaded. Every year of inaction closes doors you can't reopen. If you want to see how we might build those bypasses and keep our island bright, here's what to do next. Watch the next film in this series for a concrete roadmap. Early captures, corridor seating, and cluster grade meshes you can model today. Share this episode with one person who cares about long timelines. Reach multiplies when networks are still intact. Leave a comment with one early move you deprioritize, capture, archive, or energy relay. We'll feature the best plans in future breakdowns. Join our build list. I'll send you models, references, and step-by-step exercises to prototype these ideas at lab and classroom scales. Subscribe now, because what happens next depends on what we choose to build today, patiently, locally, and before the window narrows further.